Okay, I think we'll get started. I'm going to run through some slides and then I'm going to be sharing my screen. At any point, if you can't see something or you want me to zoom in or anything, let me know in the chat or the Q&A. We're going to do about a 10-15 minute long demo. And then I'm going to reserve the remaining 15 minutes or so for live Q&A. You can ask questions and I'll dive into the actual product and show you how things work. So please ask lots of questions, otherwise this doesn't work. And I think there's enough people here that we can kick right into it. Cool. Welcome to How to Hex. I'm Izzy Miller, developer advocate at Hex. And today we're going to be talking about Snowpark, which is a library created by Snowflake. It's very sort of similar to Spark. So if you're familiar with doing big data processing with Spark and you're a Snowflake user, or if you're an existing Snowflake user and curious about using some of these tools, this should be a pretty cool, super crash course into both what Snowpark is and how you can get started with it in Hex. I actually gave a full hour, maybe 90 minutes long hands-on lab session on Snowpark and doing churn modeling with Snowpark about a month ago. And I'm going to drop the link to this in the follow-up communication. So if this 15-minute demo wets your whistle for more Snowpark and Hex content, don't worry, there's hours more of it that we'll be providing in email. And I have a couple of slides ripped from that hands-on lab presentation that I'm going to use to set the scene for what Snowpark is in case there are people here who are unfamiliar with it. And then after a slide or two, we'll jump right into a live demo in Hex. So what is Snowpark? Snowpark is really a set of Python libraries, or well, there are other versions besides Python, but Snowpark for Python is just a set of Python libraries that let you use Spark-like syntax in Python to run Python code, whether it's for data pipelines, feature engineering, transformations, or actually machine learning and model training, inference, deployment in your Snowflake warehouse. So you can be in a Python context writing Python code, but all of the code that you're writing is being executed against your Snowflake data in your Snowflake warehouse, and no data is actually leaving your Snowflake warehouse at any time. So you don't have any security and governance questions about sucking data down into some local environment or into a third-party tool. All your data stays in Snowflake the whole time you're using Snowpark, even if you're doing a machine learning model building run, or running a super complex data pipeline. And if any of you are familiar with Spark, you don't have to deal with any of the operational and infrastructure complexity that usually comes with things like that, spinning up an EMR cluster and then running a Jupyter notebook on that and then remembering to turn it off when you're done so that you don't burn a ton of money. It's sort of the same way that you can interact with Snowflake's SQL API, where you run a query, it automatically starts a warehouse if one isn't already active, runs your workload, returns your results, and then after a short idle period, automatically spins down the infrastructure and stops billing you. So essentially, Snowpark is a way for you to take your Python workloads, whatever they might be, anything from a data pipeline to an app to an ML model workflow, and run it in Snowflake's incredibly powerful, massive, automatically distributed data centers without you having to worry about any kind of data transfer security issues or any kind of infrastructure management. So that level set done, I'm going to be showing you examples today of both vanilla Snowpark, I guess you could say, which is much more the data frame API that's very Spark-like, and then also a package called Snowpark ML, which is Snowpark's purpose-built machine learning package that maps almost one-to-one to sklearn and XGBoost. So I'll show you exactly how that works and what the little tiny differences in it are. So we're going to cover this kind of whole end-to-end process today. We only have about 10 minutes. So like I said, it's going to be a bit of a crash course, but I hope that I'm able to highlight the fact that you can use this tool inside of Hex to do the complete life cycle of a data project, from initial ingestion, preparation, transformation, all the way through training, deployment, and inference. Without further ado, let me jump into Hex and show you how this actually works. So you should all be able to see my screen now. Let me zoom in a few ticks just so that you can see. And please let me know in the chat or Q&A if you can't see anything, or if you want me to go back. I'm always happy to. So I'm actually going to jump into a different project for starts to show a really simple example of how this works. This is a Hex project. I'm not going to dive into all of the nitty-gritty of what Hex is and how it works here. But the short TLDR, if you're unfamiliar with Hex, is that Hex is a notebook-based tool for doing data science and analytics. You have cells, you have Python cells, which we're working with here, and you have SQL cells, which you can use to run SQL queries directly against a data warehouse and get your results back as a data frame that's accessible from other SQL cells or Python cells. And then you have a whole mess of other native cell types that we've built. But the bread and butter of it is a really flexible notebook interface. So we're in a Hex project right now, and I'm gonna walk through a really quick Snowpark use case. The first really cool thing that if any of you have used Snowpark before, you'll probably immediately notice is that it's really, really, really easy to authenticate into Snowpark using Hex. And we actually have this button that we call the easy button for Snowpark. And on any data connection that an admin has created in a Hex workspace, so this is a Snowpark optimized demo connection to our data warehouse. It's all been configured securely on the back end. Like the data analyst, never had to handle the credentials. I don't have keys and environment variables and whatnot. A sort of sysadmin set this up. I didn't have to touch any credentials. And now as a user, I can just click get Snowpark connection, and I get this little 3-line code cell plopped into my Hex notebook. And we have a convenience package called Hex Toolkit that facilitates the whole Snowpark authentication process. And if we run this cell, it will return a Snowpark session. If we return this, we have an authenticated Snowpark session that will basically let us run Python code against our Snowflake warehouse. Like literally, I know it's a little underwhelming because it's 3 lines of code, but with these 3 lines of code, we've instantiated a connection to our, like infinitely scalable, arbitrarily powerful Snowflake warehouse, so we can run pretty much any Python code we want against. So it's easy to gloss past those 3 lines of code, but pretty cool. The second really, really, really cool way that Hex facilitates a really tight integration with Snowpark is that any SQL cell running against a Snowflake data warehouse can actually return a Snowpark data frame instead of a Pandas data frame. So the default return mode for SQL queries is a Pandas data frame, which returns results into memory. You'd have a data frame with 885,000 rows. That's not that many, so it's not a big deal. But if you were working with, say, 885 million rows, it would be a problem to bring that much data into memory. You would probably blow up your kernel, things would get slow. You'd probably have to start working with a subset of it, and it would start to get complicated. And the really, really cool thing about Snowpark that works really, really well with the method of Hex's sort of iterative cell-based notebook development lifecycle is that Snowpark data frames are lazily executed. What that means is that when I run this cell in Snowpark mode, it's going to execute a query, but it returns really, really, really fast. And that's because it's actually only returned a couple rows of the query to show me a preview. So we're previewing 10 rows here. And the actual Snowpark query that's been constructed hasn't been completely executed yet. And we can see this if we call data frame, which is this result set. We can see it's a Snowpark data frame right here. I don't get the results dumped out. I get a pointer to a Snowpark data frame object. And this might seem like, what? I wanted my results. But this is actually incredible, because what this means is that we can now chain logic together and sort of to construct really complex queries iteratively on a potentially massive data set using this very, very, very Spark-like syntax. Like this maps pretty directly to Spark data frame API. And then when I run this code, it's actually not going to execute that either. So it's not blowing up my kernel either. And if we call filtered retail SnowDF, we just get another Snowpark data frame object. And if I want to show the results, I can run a .show command and pull these in, and I get that 10-row preview that executes really, really, really fast. And then if I do want to get all the results, I can collect them. And this will go off and actually run that lazily evaluated query and return all of my results back. And as you can see in this project, you can sort of take this down the rabbit hole as far as you want to go, breaking it across cells, chaining a bunch of filtering and grouping logic, adding in aggregations, and then the code will only execute when it needs to execute. So you can work in this really, really, really efficient, fast way, getting previews of your results. And then at the end, once you're like confident, okay, I've worked with these previews, I know exactly what I want, you don't have to go back and remove a bunch of limit 10s or something like that. You can just run .collect instead of .show. Okay, we're running out of time. I want to show one more really, really cool thing, which is Snowpark ML. So this is another project. Again, I'm pulling in some data about churn from a demo churn data set. I'm returning it as a Snowpark data frame. I get this features Snowpark data frame that, again, isn't in memory. It's being lazily returned. And then I'm going to blast through this project pretty quick, but I just want to, again, sort of emphasize that whole end-to-end lifecycle thing. And the crazy thing to keep in mind is that across this entire notebook, what I'm about to show you, none of the data is, or none of the compute is running in Hex's servers. All of the compute, every piece of Python code, every piece of SQL code, everything you see is running inside of the Snowflake warehouse we've attached here. The data is never leaving Snowflake. Nothing is being sent over the wire until I run that final .collect or .show. So we get some data on our features about this churn data set. I create a stored procedure in Snowpark to upsample this data set using imbalance learn to sort of feature engineer it and balance it for model training. I'm, just doing a SMOTE upsample here, and then I'm actually writing this data set back to a new Snowpark or a new Snowflake table. I could return it just as a raw Snowpark data frame, but I might want to use it again in the future. So I'm writing it to a new table. I register that that stored procedure, and then I call that stored procedure. And again, nothing has happened in Hex's AWS servers. All of the compute, all this upsampling has just happened inside of the Snowflake warehouse. And then I can run another SQL query in a SQL cell against that new sampled data set I've just created, again, returning it as a Snowpark data frame. So we have here our pointer to that data frame. And then I run through sort of some exploratory analysis. I'm like, okay, did that balancing work? Yeah, it did. We have our 50-50 split. And this is the really cool thing. If you're familiar with sort of sklearn and XGBoost and a couple other modeling libraries, Snowpark ML is a library provided by Snowflake that has wrappers around most of the commonly used classes and methods in sklearn, XGBoost, and a few other ML libraries, where the API is almost identical to an sklearn random forest classifier, but it's been wrapped in some clever sort of Snowpark code that when I call this random forest classifier, it's going to bundle it up into a crazy complicated SQL statement that's actually going to get executed against my Snowflake warehouse. So I'm going to go through this and pretty much do exactly the same thing I would do if I were just training a normal local model here, but all of the compute, as I've said a million times, is going to be running in my Snowflake warehouse. So I scale the data, I split it into a train test split. Again, these are all Snowpark data frames, so I'm creating these train test splits, but they're not actually returning in memory. And the cool thing to remember here is that that means these could be arbitrarily large, and I don't need to worry about infrastructure at all. And then I train my model. If you are familiar with this code, you'll notice that this looks a little bit different because I'm just passing in a Snowpark data frame and I'm not passing in like an X and a Y. That, as far as I've figured out, is the only difference in the Snowpark ML random forest classifier API to the sklearn one. You pass in the full Snowpark data frame object instead of the split features. We fit our model. Again, this is all running in Snowpark or in Snowflake, and then we can test our model and get some results. And I've run this already, and our model is trained, and it's lovely. And then we could deploy this again into our Snowflake warehouse, and then anyone with access to that Snowflake context, so like in another Hex project, in a SQL cell, or in a Snowpark session, can call that model as a user-defined function and use that model in some operational pipeline or in another app. And down below, I have sort of an example of the kind of thing you might build in Hex on top of one of these models you've trained. So creating like a flexible interface to, okay, like if I have a user who has used a lot of data and has had their account for a while, but they have a bunch of overage fees, how likely are they to churn? And we can build that out as a Hex app, and it's making calls against our Snowflake warehouse to, get that data set to predict off of, get that model that we've trained all entirely in Snowflake, and then return us results. And we're 53% confident that this user will not churn. And at the risk of saying it for the 10 millionth time, I do think it's pretty cool that like the whole process of this entire data project, from the initial exploratory data analysis to feature engineering, transformation, balancing, scaling, model training, model deployment, and model inference, 100% of it happened inside of our Snowflake warehouse. I think that's pretty cool. And before I opened up for questions, and I'm running a couple moments over, I wanted to pop over to our Snowflake history and like prove it, what I'm saying basically. And you can see that we have these queries in our Snowflake query log that show these kind of crazy queries that are being run against our SnowML batch inference input table, which is like all of the stuff that the Snowpark API handles for you that you don't have to deal with, to create temporary functions, craft these queries, and then run a SQL query that returns our predicted probability of churn. So if you didn't believe it, here's the proof that this is actually how these models are running. And with that, I will open it up for questions. I see that there's a couple already. Please pop them into the Q&A. They can be about Snowpark, about Hex and Snowpark, about the integration, about Hex. I'm happy to cover absolutely anything you are interested in. Okay, Gonzalo asks, are there any advantages to using Snowpark versus pure SQL for data transformations? Yeah, it's a great question. I think that what it comes down to, and this is actually part of like the whole Hex ethos, I would say, it's about like using the right tool for the right job. And sometimes that means personal preference, right? Like some people just like Python more than SQL. A big part of Snowpark is just giving people who are more Python oriented a toolkit to access the same like scale of compute as people that prefer SQL are. But there's also just really specific times when it's more fun or more efficient to use SQL versus more efficient or more fun to use Python. I think actually a pretty cool example of that is my little feature engineering query here, where I know SQL. I know that Snowflake has this phenomenal exclude parameter, which I'm a super heavy user of, where you can get every single column from a data set except for one, instead of having to write out like, a ton of different things here. I actually don't know how I would express that in the like Python Spark data frame API. So I prefer to use SQL for it. But then, later on, I need to do this upsampling process. And again, this is probably the kind of thing that if you were some crazy math whiz, you could do in SQL. But it just makes more sense in Python because I can just import the imbalance learn library. And the whole Hex ethos and like why we've built a workspace that has Python cells and SQL cells right next to each other is that it's like use the right tool for the right job. Run a SQL query because it's simple to do a count star, and then import a geospatial manipulation package so you don't have to calculate haversine distance in SQL. So I think that the like which one is better, I really think it's just about options, to be honest with you. Really quick, David, yeah, the demo notebooks are available. I'm gonna share links to them and also to that full hands-on lab tutorial. So you'll have all of that. Someone asks, at what data size level does it make sense to move to Snowpark? Yeah, It's also a really great question. Ruby's like, I prefer the slightly faster iteration speed of in-memory, but it's good to know the limit. I mean, there's no hard and fast limit. It depends on your architecture or your infrastructure. So right now, I'm running this project in a medium-sized hex kernel with 8 gigabytes of memory. And so I can probably fit, I don't know, like less than 100 million rows, probably, maybe 100 million rows. I mean, pandas is pretty memory inefficient, and it can sometimes like use up memory in confusing ways. I don't know if you've experienced this too. It's like your data frame is in one shape and it's taking up like a gigabyte, and then you do something else to it, and all of a sudden it's like, it's like 3 gigabytes now. So it depends on how much of your own compute you're willing to throw at the problem versus wanting to use Snowflake's like sort of auto scaling compute. I would say when you start getting into the like high hundreds of millions of rows, it starts to become a pain in the butt to work with data locally a lot of the time. Honestly, for 2 reasons. One, because you're like blowing up your kernel often, and the really terrible thing about blowing up your kernel is like you lose everything else that's been in memory, or at least this is what I hate about it. Like it's like, okay, I'm on step 50 and it's like, oh shoot, I just blew up my kernel with a huge like pivot, and now I've lost all the results of those 50 cells. And they're like, oh my God, that's like hours of work. And so using Snowpark on larger data sets can be like a hedge against that. You know, it's like, oh, worst case scenario, like, I don't know, query takes a long time and you cancel it and you craft it better, but you haven't lost your work. So that's my take on that. Can Snowpark run any Python library? You can package up any Python code as a stored procedure or a user-defined function, like I showed. Where did I show it? Here. The reason I'm doing this actually is because Snowpark ML, the like provided really neatly wrapped up APIs around some ML functions, doesn't actually support Smoke. They haven't added it yet, but I wanted to use it here to do upsampling. So I wrote myself a little stored procedure. So right, you can think of Snowpark ML as like a pre-prepared like convenience library, but you can create your own stored procedures that run any code you want. And you can actually package up specific versions of Python packages or specific Python code and provide those to the UDFs or the stored procedures. And these like run automatically in distributed fashion. Like if you write a UDF, Snowflake will like automatically distribute it and run it in parallel. And you don't have to worry about like, you know, Spark RDD, like distributed processing stuff, which I think is really cool. Let's see. Bjorn has a cool question about like Hex stuff. Can you talk about how you'd collaborate with a team on this notebook? And are there ways to version control and set up deployment pipelines for multiple environments? This is a great question. I think one of the really neat things about Hex is that it is like fully live Google Docs style multiplayer. I wonder what the best way to show this is. Maybe I'll like, well, I think it would take too long to open this in an incognito window. But if I go into a project that other people have been in, I can see the folks that have been in here recently. Like Jenna was in here on January 16th. And if other people are in this project with me, they can lock a specific cell that they're working on. So I don't like edit the line that they're on exactly, but I can be working on another part of the project, running code, and we're all in here together, like talking, leaving comments, seeing the same version of the data. And yeah, there is version control. There's both like a built-in version history mechanism. So we can see changes that I've been making and the various versions of this project that have existed. And you can sort of like step back and forth through them and revert to them. And then there's also a Git integration. I don't have it turned on for this project, but you can sync your projects to Git, and then you can actually require pull requests in order to publish a new production version of the project. We're actually building some really cool new stuff here. So if you're interested in specifically version control and collaboration, keep an eye on our changelog because there's some cool things coming. Simon asks how package management works in Hex. There's 2 ways that it works. One way is that we ship a sort of like standard library, I guess you could say, of pre-installed packages. You can see it down here in the bottom left. And pretty much anytime anyone has ever asked us about a package, we've added it. So we've got quite a bit of packages there. We pin these to very specific versions because, you know, we have to like manage all of the code dependencies. if you want a package of your own, you can just pip install any package in your Python notebook, pip install, PyPy kernel, and you could do it at like a very specific version number. You run that, and then for the life cycle of this kernel, you'll have that package installed. We also support custom packages from like your GitHub. So if you have your own like custom packages your enterprise uses, you can sync a GitHub repo, import packages, and they'll be available automatically in all of your kernels. There's also one last way, if you are a like big enterprise company and you want your own images with like really, really custom dependencies or like custom, like deep level driver requirements and stuff, you can actually give us a Docker container and we'll put that Docker container into our infrastructure. And then when you open a new project, you'll be able to, in addition to like Python 3.8, Python 3.10, you would be able to select from a list of your custom Docker containers. And we have a lot of like certain industries I feel like need this. Like we have some cool biotech customers that have like really, really, really specific environment requirements, and they have some custom kernels that we've created for them. Okay, we have a few more minutes and there are a few more questions. Ben asks, are there future plans to incorporate Jinja when constructing Snowpark data frames via a SQL cell? Oh, that is a great question, Ben, and you may know something about Hex that I do not. I wasn't aware that that didn't work in Snowpark SQL. I think it should. If it doesn't, I'll check on it and I'll get back to you about that. Okay. Alex is wondering, does data need to be modeled in a specific format to be utilized by Hex Magic? Okay, so this is like a Hex specific question for those not aware. Hex Magic is our AI integration that lets you basically ask questions about your code, edit it, generate new code using an LLM right in a Hex project. So we could say like, split this on a comma instead of period, and it will rewrite our query with the help of AI. The question specifically about do you need to model your data in a specific way? The short answer is no, you don't need to model your data in a specific way, but you do need to tell Hex how your data is modeled. And the way that you can do this is with the data manager. If you haven't seen the data manager yet and you're using Magic, this will like change your life, I promise. It's basically a data dictionary tool that's built into Hex and custom designed to tune Magic to your company's data. So you can see that on our demo workspace, I've excluded a couple of schemas or databases actually, and also excluded and prioritized certain schemas. And so Magic will rank the prioritized assets here more highly when it's looking for the right data to use. And you can do this all the way down to the table level and all the way down to the specific column level. And let me find one that's really nicely built out. Basically, this lets you give Magic guidance and information about how to treat all of these fields. So here I say like only filter on order status equals canceled if the query also contains raw square POS data. And you can get like pretty crazy with the guidance that you give to Magic here. Everything from giving it examples of what the actual order IDs look like so that it can do some complex string splitting, to giving it like actual semantic information about what kind of like how your orders work. So that was a very long answer, I guess, but the TLDR is model your data however you want, just make sure you tell Magic about it. I actually have a blog post about this called Managing Magic on the Hex blog that has a ton of examples and like really, really, really specific guidance on how to use a data manager to make the most of Magic. And it will radically improve the performance of Magic for your organization, I promise. Okay, I guess we're over time. If you have more questions, feel free to email me, reach out to us, however, and we'll get them answered. I'll follow up via email with you all and include links to both the project that I walked through and that churn model hands-on lab that I did with Snowpark, ML, and Hex. So if you want to learn more about Snowpark and Hex, you can get started with it. If you haven't used Hex and you'd like to after watching this, it's very simple. just go to hex.tech and click get started. Sweet. Thanks for coming, everyone, and I'll see you next time.